In this video, I'll be walking you through on higher derivative of Jacobian. Higher derivative of Jacobian. Now, before we proceed, this is Further Solutions Academy. Further Solutions Academy. Please encourage us by subscribe and share to your friends. Please do this for us so that to encourage us of doing more. Drop your comments, everything will be attended to. Once again, this is Further Solutions Academy. Okay, today's video, I'll be walking you through on what? Higher derivative of Jacobian. Now, before we proceed, this is Jacobian. Jacobian is more of what? Partial derivative. Is more of partial derivative. Now, and we have done higher derivative of normal differentiation, which we'll be talking about d of y with respect of what? Of x squared. I can run this through to what? To my of n, which is my n term. Now, which is I'm working on total derivative. And also note that if I'm talking about the total derivative, this of y and of x is not the same thing as what? Of y and what? Of x. They are very different. This is partial derivative, while it is total derivative. Now, why this Jacobian is all about what? Partial derivative. Partial derivative. Now, and in our previous video, I let you know that what? If I have my f of x can also be what? Of y with what? Of x. Now, it means a function. Sorry, let me put a function here. Now, a function of what? Of x. Now, also, and you can get that, but this time around, we'll be talking about what? One or two at a point. Now, okay, for instance, if I have my square of f of x, this is same thing as f of x. Now, if I have f square of y into of y and also of x, this same thing as f of x and y. It means I will work on what? X first, and after I work on what? On y. Now, also if I move on to what? F function of x of y. This is given as what? Of what? Of y of x. It means I work first on y. I'll also move on to what? To, and so on and so forth. This can happen like that. It may be in what? I can have, it's possible to have something like this. Also, and of my f, I have x squared and what? Of what? Of y. It's possible. And so on and so forth. Okay, now let's go to example. Let's go to example. Okay. For example, I want to obtain f of x, comma, f of x, y, comma, f of y, x, and f of y, y. In for the following functions. Now, let me call this function. I have one. Okay, the function one can be, let me use f of xy can be equals to 5 raised to power x raised to power 4y cube and plus 2xy. That is number one. Number two, I have z equals to e raised to power x squared plus y in the power form. Now, I want to solve this particular problem, solution to this problem. Now, let me divide this into two. Now, I have this particular problem to solve. How do I solve it? What I need is, I need this, I need this, I need this, and I need this. Now, this is what I need now. Okay. Now, what I will go for is that I will start from what? F of what? Fx of the first one. F of x of the first one. It means I want to consider only x, which I will be having 20 of s3 y3 plus what? 2y. Now, the first one is what? F of xx, which is f of xx. It means I'm to consider what? The x on second stand, which I will have what? 20, which is I will be having 60x squared y3 plus what? 0, which is s is what? Of 0 here. It means whenever I do that, it turns to what? 0, which I don't need that. Now, okay, if I move on to what? S of y. It means if I should get my s of y, at this point, I will consider only y, which I will be having 60 s raised to power 3 y squared plus what? Plus 2. Now, and the next one is what? F of y. My f of y, it's from here. My f of y, for my question, my f of y, it will be having 15 s raised to power 4 y raised to power 2 plus what? 2x. Now, if I have f of y, my f of y, it will be, I will be having 30 s raised to power 4 y plus what? Nothing, because y here, there's no y. That one is settled. Now, if I move on to f of yx, f of my yx, it will be my yx. Now, at this point, I want to consider, now, 5 times 4, it will be 5 times 4, which is 30, that will be 60. I'll be having 60 s3 y squared plus what? Plus 2. Now, what I want to achieve, I want to achieve this, I want to achieve this, and I want to achieve this, I want to achieve. The first question is solved. The second question is, I'm having z equals to ex squared plus y squared. Now, the first one is, I want to consider x of x, it will be what? 2x e raised to power x squared plus y squared. Now, in the next stand, if I want to go for the next one, this one become a product rule. Now, my z of x, it will be equals to, because it's a product rule, I will differentiate one, old one. If I should differentiate with respect, this one will be u, this one will be what? V. Now, since that, it means I will be having, now, I'll be having what? I'll be having 4, because my s is coming down. Okay, the first one will be 4 s squared e raised to power s plus y raised to power 2 plus, because product rule. Now, if you don't understand product rule, go to our previous introduction to calculus, introduction to differential calculus. Now, which is, I will also move on to what? If I should do this, I want to consider the other one, which it will be 2 x squared plus y squared. If you want to show that you know what you are doing, you can factor out what? E of what? Which also implies what? E s squared plus y squared bracket of what? 4 s squared, sorry, this one is not there, plus what? 2. Or you can put 2 here, which I have 2 here, and I have 1 here. There won't be any issue. Now, that is my answer for that. Now, if I move on to what? My z of what? Of s of y. Now, it means I want to consider my y at this second stand. It means I'll be having, if I should drop down, 4xy e raised to power what? S squared plus y squared. That is for that z of x. Now, if I move on to of y, z of y, I'll be having c of y will be 2y e raised to power what? E raised to power x squared plus y squared. Now, if I should move it to what? Z of y, it will be z of y, it will be, which is product rule. The same way, it will be 4y squared e s2 plus y plus which is I have the second one will be what? Plus 2 es squared y squared. Now, which I can do the same thing, which I can factor out 2 and what? E raised to power s plus 1. Now, if I should move on to what? E of yx. My e of yx will surely give me what I want to, which is I want to consider x here. It will be what? 2xy e raised to power what? Which is 4. Sorry, 4xy e raised to power what? S squared plus y squared. That is my final answer. What I want to achieve, I want to achieve this, I want to achieve this, I want to achieve this, and I want to achieve this. That is all. That is all. Now, okay, that is all about, that is on higher derivative. I can go for 2, 3, 4, and so on and so forth. Now, let me bring out some problem can give us problem. That can give us tough time, maybe during exam or any of our proof. Okay. Once again, this is Further Solution Academy. Help us to share and subscribe. Now, let me bring out 2 questions and I give exercise to work on. For instance, we have to show that my function, my y equals to fs plus 80 plus g of s minus 80, okay, plus 80, okay, which satisfies now, which satisfies e square of f all over of what? Of x of t rather squared which satisfy, okay, this of this equals to a square of f bracket all over what? Of s squared. Now, this is very, very simple. What I want to do here is that I will consider my x and also consider my what? My t. Now, solution to this problem. Now, what I will just do is that I will have my what? Now, if I should solve, I can start from what? Let me start from t. If I should have my fy of what? Of t, I will have what? I will have a f prime of x plus st plus y, which is a prime of what? S minus what? Minus 80. Now, which is okay, this one there will be minus here because of what? That minus will come along with what? With that a. Now, if I should move on to what? My y square of y of t squared, which I will be having a squared f prime prime. When you see prime prime, it means differentiates. Now, this one will be plus. That second minus is coming, which I have a squared g prime prime of what? S minus s. Now, which I can write this as what? A squared f prime prime of s plus 80 and plus a squared g prime prime. Okay, this is not there again. Prime of. Now, I close the bracket. I factor out the a. Now, which this is what? This is achieved first. Now, the second one is what? I will go for what? Of e of f all over what? With respect of x, which at this point I want to consider my what? My x. What I will just do is that I will differentiate this is 1. Bring out the differentiator, which I have f prime of what? S plus at plus g prime of what? S minus at. Now, if I move on again to square of s squared, which I will have f prime prime of s plus at plus g prime prime of what? S minus at. Now, I can now state my condition. The condition states that what? This is equals to this, which I have e of what? Of f all over what? Which it can be equals to what? A squared of all over x squared. Now, can you see that this is equals to this? Why? Because of what? You can see that what? Now, my this is what? A squared bracket of what? F prime prime of what? Of s plus at plus f g prime 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 of what? S minus at close your bracket, which is equals to, now attach your a. I have my a, which is this my a. Now bring your what? I have bracket of what? F prime bracket of s plus at plus g prime prime bracket of x minus at. Now that is all. They are equal. Once they are equal, it means it's satisfied. That is your solution. This can come out in any exam. That is my what? My solution. Now, I can move on. Let me give another problem that can also give another question like that. I want to be on 2 examples on this part. Now, if I have a problem like this, which is we are calling upon harmonic. When you hear harmonic equation, it means their sum up is equals to what? Is 0. Their sum up is equals to is 0. For instance, if a function fxy equals to is a function, I mean is said to be harmonic. It's said to be harmonic if of f all divided by of x plus of equals to 0. Harmonic means that sum up is equals to what? Is 0. It must be equals to 0. Now, also is called what? You can call it Laplace. You can also call it Laplace. When we get there, under our differential equation, ODE, second order, third order, you will see how that happens. Now, show that f of xy equals to ln root of x squared plus y squared. Now, y squared is harmonic. Now, harmonic function means that function, the sum up is what? Is 0. Now, solution. This is very simple. Whenever you have this type of problem and you are asked to solve, how do I solve it? It's always simple. What I will just do is that, if I have ln root of what? S squared plus y squared. Okay, let me introduce brackets. This also can be the same thing as what? Ln s squared plus y squared or bracket of 1 all over 2. Now, if I should apply my law of logarithm, I can also have 1 all over 2 ln s squared plus what? Y squared. Now, these are all the same. Now, with the law of logarithm, we will understand that. Now, I can now move on. If I have my function of x now, It means I want to differentiate with respect of x. Now, this is called function of function. Differentiate inside, inverse of inside. If I differentiate inside, I will have 2x. Now, and I'm having 1 all over 2 here, divided by, I will have inverse of what? Of this. Which 2 will cancel this. Which also x all divided by what? X squared plus y squared. That is for that. Now, if I should move on to what? F of f, which is what? I'm working towards what? Towards this now. Now, if I should work on this thing, this one become a what? Quotient rule. Your quotient rule, go and learn it in our previous video. Now, this is v, this is u. They are both function of what? X. X. They are both function of what? Of x. Now, example, that application of it is when you have a fruit and you are having a what? Apple and orange. Apple and orange, they are function of what? Of fruit. That is function of that. Now, they are very common in product rule and chain rule, even function of function, the same thing. Now, we have done all those time. Now, how do I differentiate this? I will differentiate. Hope you know this one. If I differentiate this, it will give me vu prime minus what? Uv prime divided by v square. That is the differentiation. Now, okay, it means with the help of that, I will have what? I will have y squared minus x squared divided by xy, okay, or bracket of what? Of square. You can use your chain rule. Now, which is my f of x, which also the same thing as what? My square of f bracket of what? X square. Now, I can move on to what? My f of what? Y, which I will be having the same way, y divided by x squared plus y squared. Now, if I should, I'm coming from here now. Now, if I should go again and again, if I should have my f of y, y. Now, my f of y, y, my f of y, y, it will be equals to, my f of y, y, it will be equals to, my f of y, y, it will be equals to, okay, my f of y, y, it will be equals to, I will be having, it will be equals to x squared minus y squared divided by x squared plus y squared or bracket of what? With our quotient rule. Now, what I want to satisfy is that my what? My f of sx plus my f of yy are harmonic. Which is, what am I going to do? What is my f of sx? My f of sx is what? Y squared minus x squared divided by what? X squared plus y squared, okay, squared, plus, what of this one? I have x squared minus y squared divided by x squared plus y squared or bracket of squared equals to what? 0. Can it be equals to 0? Once you are having 0 on your LHS, now the LCM is this will cancel this, and this will cancel this. I think from your fraction, with the help of your fraction, normal fraction in a basic number, these are the same. You find the LCM and you go. Now, you are having 0 divided by what? Function of what? F of x, which is equals to 0. Now, 0 is equals to 0. That is my final answer. Now, at this junction, we'll be going to the end of this class. Go to any textbook, get more material. With what we have done here in this video, you should be able to solve or tackle any problem on higher derivation of what? Jacobian, which is partial, PD, which is partial derivation. Now, next video we'll be working on trigonometry. We have covered much more on, most of everything on differential calculus. The next one will be working on what? Integration. After integration, we'll move on to what? Hyperbolic function. After hyperbolic function, we'll move on to what? ODE, ordinary differential calculus. After that, Laplace, second degree, third degree, and so on and so forth. A lot are coming to your way. Many are coming. Just keep on to our channel, Further Solutions Academy. Further Solution Academy. Make sure you solve as many as you can. Drop your comment, it will be attended to. Once again, Further Solution Academy, encourage us more by sharing and view our video. Thanks for watching.